In Part 4, you'll learn how to prepare the hard drive for an operating system. You'll learn how to set up and optimize the partitions on the drive. Then you'll learn how to load an operating system. Before we format the drive, let's go over several configuration settings and options. Let's start with hard drive parts, file allocation table, partition type, RAID options, and finally, hard drive size and configuration options. Let's start by looking at the internal parts of a hard drive to help understand how data is stored. Data is written and stored on individual platters that reside inside the hard drive case. These platters are covered with special magnetic materials on both sides. The platters of the hard drive spin at very high speeds. These speeds are measured in RPM, which stands for revolutions per minute. This means how many times an object spins in a complete revolution in 1 minute. Hard drives spin at thousands of revolutions per minute. The faster the hard drive spins, the faster the data will be read. To store files on the hard drive, the read and write heads, which are located on the actuator arm, send small magnetic charges onto the surface of the platter. The data is written onto the platter starting from the center, working its way outward. It will use the next free space to store the data. The file allocation table, referred to as FAT, resides on the beginning of the volume and is named for its method of organization. What is the file allocation table known as FAT? FAT16, FAT32, and the newer technology, file system, known as NTFS. The numbers in FAT16 and FAT32 refer to the total bits for each storage unit. FAT16 uses 16 bits as FAT32 uses 32 bits. NTFS actually uses 64. To protect the volume, 2 copies of the table are kept, in case one becomes damaged. In addition, the file allocation tables must be stored in a file location so that the files needed to start the system can be correctly located. This is done by locating the table in the master boot sector, which is the first 63 bits of a bootable disk, floppy, or hard drive. This, however, is not visible. The FAT follows the boot sector. Each logical volume has its own FAT, which serves 2 important functions. It contains the allocation information for each file on the volume in the form of linked lists of allocation units, and it indicates which allocation units are free for assignment to a file that is being created or extended. The FAT file system is simple and reliable. It does not lose data because the computer crashes in the middle of an update. It doesn't use a lot of memory also. It does, however, do a lot of extra administration input and output to different areas of the partition. The directory is allocated at the start of the partition, and it contains the table of free space. To write a new data set or to add data to an old one, the disk arm must be constantly moving between the locations of the directory and the place where the data is being written. Without optimization, a file can end up fragmented into many small pieces. When the system crashes, no data is lost. However, a FAT system may have removed disk area from the chain of free space. but may not have yet assigned it to the permanent new dataset. The check disk or scan disk ultimately examines the FAT table to determine the status of every record on disk. The records, which are not part of any dataset, may be returned to FreeSpace chain. After check disk finds unallocated sectors, it asks you whether they should be turned into files. If you were in the middle of creating a new file and the system crashed and the data was lost and is extremely valuable, you might answer yes. If you do answer yes, you can scan the recovered file scraps for information that you lost. Otherwise, answer no and the unallocated space will be recycled as free space. If the FAT table becomes corrupted, or what is known as disk errors, there is a second table available for programs like ScanDisk, which is used to fix the FAT table. A corrupt FAT can cause you to get messages, "No bootable media." At this point, if ScanDisk cannot fix it, you will need to format and start over. It is recommended that you low-level format and reinstall Windows. If the Windows Setup program complains about the drive, you'll have to replace the drive with the new one. By design, FAT supports a maximum of 64K allocation units. When the disk partitions is 32 megabytes or less, an allocation unit is a 512-byte sector. However, as the disk gets larger, the units get larger. A 64 megabyte disk partition has 1K allocation units. A 128 meg partition has 2K units. A 256 meg partition has 4K units. Each file occupies one or more allocation unit. As the allocation units get larger, any larger number of small files wastes a lot of disk space. A classical FAT directory structure before NT in Windows 95 limits file names to 8 characters with a 3-character extension, as in the name autoexec.bat. This 8.3 naming convention was borrowed from the early DEC mini-computers. The FAT structure also maintains for each file a set of attributes such as system dataset, should it be hidden in the directory display. Should it be archived next time the disk is backed up, and it is read-only. There is also a date and timestamp when the file was last changed. FAT has been around for a long time, so its problems have been carefully studied. Every version of DOS and Windows except NT comes with a defrag program that will reorganize the directory files and free space to maximum performance. Effective use of RAM as disk cache can address some of the I/O problems. Next came along FAT16, which was limited to 2 GB per partition and uses 16 bits. After FAT16 came FAT32, which is a derivative of FAT file system that supported drives with over 2 GB of storage. Because FAT32 drives can contain more than 65,526 clusters, smaller clusters are used. The method results in more efficient space allocation on the FAT32 drive. The largest possible file for a FAT32 drive is 4 GB minus 2 bytes. NTFS, known as the New Technology System, has had several versions. NT3, which was used in early Windows NT days, and the newest version, NT5, which is used with Windows 2000 Professional, Windows 2000 Server, and Advanced Server, as well as Windows XP, Media Center, and Vista. The file system is completely different from the FAT16, FAT32, and quite a bit different than the earlier version, NT4. NTFS 4 cannot create dynamic partitions and is not compatible with them or with the Active Directories. The file system cannot manage RAID disks without the support of RAID adapters. It cannot read or write FAT32 files and does not have a built-in defrag utility. The master file table does not lie in the same position as the NTFS 5. It also supports smaller size partitions than NTFS 5, and its operating system is less user-friendly to PC users. NTFS 5 file systems can read NTFS 5, FAT16, and FAT32 files and can write them if there are available logical drives in these formats. Its disk utilities are easier to use, faster, and better than FDisk and format utilities. You can choose the file system FAT16, FAT32, or NTFS for each partition. You can create 1 and to 4 primary partitions, or you can create 1 extended partition and 1 and up to 3 primary partitions, and last, the extended partition. NTFS 5 file system can support larger volumes with smaller clusters than FAT16 or FAT32 because it uses 64 bits instead of 16 or 32. The size of the clusters in the NTFS 5 file system can be specified from the administrators also. If the size of the files are small, you can create smaller clusters. If the files are big, you can create bigger clusters. This way, we can save space and reduce the file fragmentation. NTFS 5's minimum size of clusters is 512 bytes, as the size of the smallest physical unit on the hard drive. Now let's review several partition types: basic volumes and simple volumes. Basic volumes include partitions and logical drives within extended partitions on a basic disk. You can only create basic volumes on basic disks. A basic disk is the physical disk that contains primary partitions, extended partitions, or logical drives. When using basic disks, you are limited to creating 4 primary partitions per disk, or 3 primary partitions and 1 extended partition with unlimited logical drives. Always use basic volumes instead of dynamic volumes on computers running MS-DOS, Windows 95, Windows 98, Windows Millennium Edition, Windows NT 4, or Windows XP Home. These operating systems cannot access the data stored on dynamic volumes. Windows 2000 and Windows XP no longer support multi-disk basic volumes created using Windows NT or earlier. These multi-disk basic volumes must be backed up and deleted prior to installing Windows XP or moving disks to a computer running these operating systems. In Windows 2000, you can restore the data to a basic disk, convert the basic disk to a dynamic disk, and then use dynamic storage to create new span volumes, striped volumes, mirrored volumes, or RAID 5 volumes. A simple volume is a portion of a physical disk that functions as though it were a physically separated unit. Simple volumes are the dynamic storage equivalent of primary partitions in Windows NT 4 or earlier. When you have only one dynamic disk, they are the only kind of volume that you can create. In the Disk Management console, you will see several partition types. Primary partition is a type of partition that you can create on basic disks. A primary partition is a portion of a physical disk that functions as though it were physically separate disk. On basic master boot record disks, you can create up to 4 primary partitions on a basic disk, or 3 primary partitions on an extended partition with multiple logical drives. Primary partitions are also known as volumes. Extended partition is a type of partition that you can create only on a basic master boot record disk. Extended partitions are useful if you use to create more than 4 volumes on a basic master boot record disk. Unlike primary partitions, you do not format an extended partition with a file system and then assign a drive letter to it. Instead, you create 1 or more logical drives within the extended partition. After you create a logical drive, you format it and assign it a drive letter. A master boot record disk can have up to 4 primary partitions or 3 primary partitions on extended partitions and multiple logical drives. Logical drive is a volume that you can create within an extended partition on a basic master boot record disk. Logical drives are similar to the primary partitions, except that you are limited to 4 primary partitions per disk, whereas you can create an unlimited number of logical drives per disk. A logical drive can be formatted and assigned a drive letter. A dynamic volume made up of disk space from a single dynamic disk. A simple volume can consist of a single region on a disk or multiple regions on the same disk that are limited and linked together. You can extend a simple volume within the same disk or onto additional disks. If you extend a simple volume across multiple disks, it becomes a spanned volume. You can create simple volumes only on dynamic disks. Simple volumes are not fault tolerant, but you can mirror them to create mirrored volumes. Now let's review several RAID options. RAID 0, which is known as striping. A RAID 0 system data is split up into blocks that get written across the drive in an array. By using multiple disks, at least 2, at the same time, RAID 0 offers superior I/O performance. This performance can be enhanced further by using multiple controllers, ideally 1 controller per disk. Advantages: RAID 0 offers great performance, both read and write operations. There is no overhead caused by parity controls. All storage capacity can be used, and there is no disk overhead. The technology is easy to implement. Disadvantages: RAID 0 is not fault tolerant. If one fails, all data in the RAID 0 array are lost. It should not be used on mission-critical systems. Ideal use: RAID 0 is ideal for non-critical storage of data that have to be read and write at high speed. This is ideal for working with large photo formats or video editing projects where one file is very large. RAID 1 is known as mirroring. Data are stored twice by writing them on both the data disk or set of data disks and a mirror disk or set of disks. If a disk fails, the controller uses either the data drive or the mirror drive for the data recovery and continues operation. You need at least 2 disks for a RAID 1 array. RAID 1 systems are often combined with RAID 0 to improve performance. Such a system is sometimes referred to by combined number of RAID 10 systems. Advantages: RAID 1 offers excellent read and write and a write speed that is comparable to that of a single disk. In case of disk fails, data does not have to be rebuilt. They just have to be copied to the replacement disk. RAID 1 is a very simple technology. Disadvantages. The main disadvantage is that their effective storage capacity is only half of the total disk capacity because all data is written twice. Software RAID 1 solutions do not always allow a hot swap or failed disk, meaning it cannot be replaced while the server keeps running. Ideally, a hardware controller is used. Ideal use is RAID 1 is ideal for mission-critical storage, for instance for accounting systems. It is also suitable for small servers in which only 2 disks will be used. RAID 3. On RAID 3 systems, data blocks are subdivided striped and written in parallel on 2 or more drives. An additional drive stores parity information. You need at least 3 disks for a RAID 3 array. Since parity is used, a RAID 3 stripe set can withstand a single disk failure without losing data or access to data. Advantages. RAID 3 provides high throughput, both read and write, for large data transfers. Disk failures do not significantly slow down throughput. Disadvantages. This technology is fairly complex and too resources extensive to be done with software. Performance is also slower for random small input and output operations. Ideal use. RAID 3 is not that common in prepress. RAID 5. RAID 5 is the most important secure RAID level. It is similar to RAID 3, except that the data are transferred to disks by independent read and write operations, not in parallel. The data chunks that are written are also larger. Instead of a dedicated parity disk, parity information is spread across all the drives. You need at least 3 disks for a RAID 5 array. A RAID 5 can withstand a single disk failure without losing data or access to data. Although RAID 5 can be achieved in software, a hardware controller is recommended. Often, extra cache memory is used on these controllers to improve the write performance. Advantages. Read data transactions are very fast, while write data transactions are somewhat slower, due to the parity that has been calculated. Disadvantages. Disk failures have an effect on throughput, although this is still acceptable. Like RAID 3, this is complex technology. RAID 5 is a good all-around system that combines efficient storage and excellent security and decent performance. It is ideal for file and application servers. Next is deciding on partition sizes. Partition sizes are entirely your preference. The size and quantity of the partitions will depend on your needs and drive size. The primary hard drive, which the operating system will be loaded onto, should be broken up into 2 partitions if 75 gigs and smaller, and 3 partitions if 75 gigs and larger. For optimal performance, the first partition, which will end up being drive C, will be dedicated for the page file system. What is the page file system? The page file system is a hidden system file that forms a key component of the Virtual Memory Manager, VMM, on Windows platforms. The origin of this file dates back to the early 1990s when Windows ran on PC hardware that had limited physical memory due to the high cost of RAM and the limitations of the motherboard design. The purpose of the page file was to allow memory-hungry applications to circumvent insufficient RAM by allowing seldom used pages of RAM to be swapped to disk until needed. Hence the term swap file used on earlier Windows platforms. The most significant performance gain you can achieve with regard to the page file on Windows is to move the page file to a different partition or volume. By default, Windows creates a page file of a size 1.5 times your RAM and locates it on the root of the boot partition. Unfortunately, this means the I/O subsystem must contend for access to operating system files in the page file, which increases disk activity and slows performance. By moving the page file to a different volume, this contention is reduced. The default page file size is 1.5 times this RAM size. It is recommended you factor the size 2 or even 3 times the size of RAM. If you are using 1 gig of RAM, you should make the page file size 3 gigs for optimal performance. The first partition should be a basic volume primary partition. The size should be 3 times your RAM size for boot record and other hidden system files that are loaded on the first primary partition. The page file system will not be loaded on the first primary partition by default. After you have loaded the operating system, you will need to move the page file system and change the file size, followed by rebooting for changes to take effect. The second partition will be a basic volume primary or logical drive. This is where you will load the operating system. If your drive is larger than 75 gigs, then you can create 3 primary partitions or extended logical drives to store files. This partition is great for storing documents, pictures, music, and any other miscellaneous files. A second drive is recommended for music, pictures, and other documents. This is where you'll want to save all files. This will keep your operating system at its best performance. A large secondary drive can be formatted using the simple format and broken up into as many configurations. If you have a TV tuner, you may want to format the first partition for media files where you can record all your programs. The second is where you can store multimedia files such as pictures and music. The third partition is perfect for files like documents, backup files, emails, favorites, etc. We have just reviewed several hard drive configurations and options. Now it's time to actually format and load an operating system. During this process, you will want to set up the primary boot partition, followed by the second partition where the operating system will be loaded. All other partitions and drives will be configured after the operating system is loaded through the Management Console. Let's get started. We will be installing Windows Vista. Microsoft has made installing Windows Vista even easier than previous versions. Before loading Windows Vista, review the compatibility list before installing. You will find the release notes on Microsoft's website located at http://www.microsoft.com/HCL. Plan your installation prior to installing. Information you will need before you start your installation. Think about the name you would like to use on your computer. This name is what others on the network will see you as. Name of your workgroup or domain. Refer to our networking section on the CD. You will need to know your IP address if you use a static IP. Typically, your ISP will assign your system an IP address when you are logged in. This is known as DHCP. The default setting will be DHCP. Gather up all driver disks that match your hardware you have installed. Vista usually will load any drivers necessary, but just in case your operating system does not recognize your hardware, have them handy. To begin the installation, simply insert the Windows Vista setup disk into the DVD-ROM drive. We will be forming a new installation of Windows Vista versus an upgrade version. When all possible, load a new install. Turn the computer on. During the boot up process, you will need to have your hand on the delete key located on the keyboard here. A side note, some motherboards will vary. Check your motherboard manual for supported keyboard commands. During the boot up process, you will have to be quick on the delete key. If you miss the setup command, simply press Ctrl, Alt, and Delete at the same time, or hit the reset button on the case. During the boot up process, verify that the hard drive has been detected. To view the settings, press pause on your keyboard to pause the boot up process. To resume the boot up process, press any key on the keyboard to resume. If the primary master reads none, then properly set the correct settings in the BIOS as discussed in the BIOS setup. Make sure you have your DVD as your first boot. During boot up, you will be prompted to press any key to boot up from DVD. During the boot up process, your computer will inspect your computer's hardware configuration and then actually load the setup files. The first screen will allow you to set up your language, time and currency format, as well as your keyboard input method. Select the option that applies and click Next. Your setup may differ from different versions of Windows and different Vista releases. This guide will walk you through a typical setup, so when you install your operating system, you will have a good understanding on the steps you will need to perform. Here we have several options. Install now, what to know before installing Windows, and repair your computer. We'll go ahead and click on Install Now. Now you need to read the license agreement, check the box to accept the agreement, and click Next. Here you can choose the type of installation, Custom, which is advanced, install a clean copy of Windows. As a side note, this option does not keep your files, settings, and programs. Go ahead and choose Install a clean copy of Windows. Here you will have several options. Refresh, which will show any changes made. Delete, if you would like to delete a partition. Format a partition. New will create a partition type and size. Load driver is for drivers that are on a drive controller and the setup process does not recognize the controller. Extend will allow you to extend an existing partition onto any available free space. With the size of hard drives today, it is recommended to break up the hard drive into 2 and even 3 sections in some cases. Whether you have a 200 gig, 400 gig, or even a 1 terabyte drive, the initial primary partition is recommended to be about 10 gigs. Refer to our hard drive section on recommended sizes and configuration. The first partition you will create is the page file partition, which will be the first partition on the drive. Highlight the unallocated free space and click New. Create a 10 gig partition and click Apply to take effect. Next, highlight the unallocated free space and click New. If your drive is 250 gigs or larger, then it is recommended to create 3 partitions, so the second partition is where the operating system will reside. This partition should be 125 gigs or larger. Since this is a small 200 gig drive, I will select the remainder of free space, which is selected by default, and click Apply. Here you can select each partition and choose Format. We will format the first partition after we have loaded Vista through the Disk Management Console. Highlight the second partition and click Next. This is where the setup will load the operating system. During the setup, Windows will format the partition. The setup process will now load the Windows setup files and prepare the hard drive for installation. Once the files are expanded, the installation process will start automatically. During the setup process, the computer will restart several times during installation, so don't be alarmed. This is a normal process. Type your username and password, then choose an icon that you would like to associate to your user account. This will be your computer administrative account, so you can create more accounts later through the control panel. Once you type in your username, type the password for this account, then retype the password to verify that they are the same. You can type a password hint to help you remember the password. Once you have typed the information, click Next. Type a computer name. This name will be recognized on the network. Then choose a desktop background and click Next. You will be prompted to set the Windows protection. Use the recommended settings. Verify the date and time is correct, and click Next. Select your computer's current location. Typical home connection is home, so click Home. Windows has now completed the setup, so click Start. A few splash screens will appear. And here you'll be prompted with your first login. Windows will prepare the desktop for the first time. You will be welcomed with the Windows welcome screen shown here. Let's connect to the internet and check the internet settings. Click on Browse the Internet now. Close the welcome screen. And here we are up and running and can now browse the internet. We will close the browser window. Now let's format the first partition and create the page file system settings. Go to the Start menu, right-click on Computer, and click Manage. And click Continue. This is the Computer Management Console. The left column is a list of tools. Click on Disk Management. This will display the drives and status of each drive. Each drive installed will be ID'd as Disk 0, Disk 1, and so on. The DVD-ROM drive will also be shown here. Disk 0 shows 2 partitions, D as 9.77 gigabytes RAW. RAW means unformatted. And drive C shows healthy and the format type is NTFS. To format the drive, right-click on the 9.77 gigabyte unallocated space. You will have a list of options. Refer to our online tutorial for more on the different options available. Click on Format, and here you can type the volume name. Go ahead and type page file for the volume name, since this will be the page file location. Here you can choose the file system type. NTFS is the recommended choice. You can also choose the allocation units. Default settings is recommended. And click OK. And OK again. And here the disk will be formatted. Once the format is complete, close the Management Console. Now let's reassign the page file system file. Click on the Start menu and right-click on Computer. Click on Property. This is the System Maintenance Control Panel. The recommended page file system size is 3 times the RAM size. The max size is less than 4096. We have installed a 1535 megabyte memory stick, so 3 times is equal to 4605. So the page file system size we'll choose is 4095, which is the maximum size allowed. Click on Advanced System Settings and click Continue. Click on Settings under Performance and click on the Advanced tab. The page file is located in the Virtual Memory window. Click Change. This is the Virtual Memory Manager. By default, the system will automatically manage the page file system. Deselecting this will allow these settings to be edited. Click on Drive D, Page File Volume, and click Custom Size to set the size of the page file system. In the initial size type, type in 4095. In the max size type, type in 4095 again, and click Set. This new setting will be displayed here. Now let's remove the system settings by clicking on Drive C. And select No Page File and click Set. Click Yes to continue. Now click OK, then Apply, and close the control panel. And now let's restart the computer. Once the system has restarted, log back in, and now let's review the device settings to ensure all drivers are loaded. Click on the Start menu and right-click on Computer and click Manage. Click Continue. On the left, click Device Management. Here you will see a display of devices. Check that there are no yellow exclamation markings on any of the devices. The multimedia audio controller has an exclamation mark, which means the device has a problem. Right-click on the device and click Update Driver Software. Here you can choose how to search for the driver software. If you have the driver disk, simply place it in the DVD drive and click Browse My Computer for driver software. The recommended choice is selecting Search automatically for updated driver software. Windows will search your computer and the Internet for the latest driver software for this device. Click Search automatically for updated driver to begin. Once Windows finds the driver will be displayed here. Once the driver has been updated, click Close, and once everything looks good, go ahead and close the Management Console. You have just seen how to build a computer. You first saw all the different parts you need to build your computer. You then learn several ways to purchase those parts. Next, you gathered all the parts together and actually built the PC. Finally, you learn how to boot up your new computer, configure the BIOS, and prepare the hard drive and actually load an operating system. Thank you for watching. We sincerely hope this video has helped you learn how to build a computer. For a complete catalog of all our computer-related e-learning products, please visit our website at www.c2learn.com.